Good morning, students. In previous lecture, we see the vector field and limit of vector valued function. Okay. Now, in this lecture, or in today's lecture, we see the continuity of vector valued function. Okay. We learn or discussing about continuity of vector valued function. Okay. Definition of continuity is, let S be a non-empty open subset of Rn. F is a function defined from S to Rn. Let here it is a vector field which is defined from Rn to Rn. Okay, be a vector field A belongs to S and function F is said to be a continuous at A. If definition for epsilon greater than 0, there exists delta greater than 0 such that norm of x minus a is less than delta implies norm of f of x minus f of a is less than epsilon. So here only difference that here we take norm in case of mod since we are in the vector field. Only this minor change. Okay, definition is same of continuity in scalar field and vector value function, but norm mod is replaced by norm here only. Okay, norm of f of x minus f of a is less than epsilon. Okay, now we discuss one theorem on continuous function, which is same like limit of the function. Okay, in previous lecture we discussing the theorem on limit. Okay, the limit of the function is exist if and only if the limit of each of the component function of the f is exist. ओके, म्हणजे त्या फंक्शनचं लिमिट एक्झिस्ट होण्यासाठी त्या फंक्शनच्या प्रत्येक कंपोनंट फंक्शनचं लिमिट एक्झिस्ट व्हावं लागतं आणि जर प्रत्येक कंपोनंट फंक्शनचं लिमिट एक्झिस्ट होत असेल तरच त्या फंक्शनचं लिमिट एक्झिस्ट होतं. असं आपण लिमिटचा थेरम बघितला. इट्स अ सेम थेरम we will proving in this continuity. Okay, if function f is continuous, then each of the function f1 to fm component function is continuous at that point a. Okay, look at the statement. Let S be a non-empty subset of Rn. F is a function from Rn to Rm. F of x is equal to f1x, f2x and so on, fmx. Since we are in vector field, A belongs to S, then F is continuous at A. F is continuous at A if and only if each of the coordinate function fi is defined from S to R. Okay, fi are the coordinate function. Fi means f1, f2 up to fn. These are coordinate function and which are defined from S to R since they are scalar valued function and these functions are continuous at A. Okay, so see the proof. First, suppose we assume that limit x tends to a, f of x is equal to f of a. That is the function f is continuous at point a. Okay, limit of this function is exist and which is equal to f of a means what? The function f is continuous at x is equal to a. So by definition of continuity, we get for epsilon greater than 0, there exists delta greater than 0 such that norm of x minus a is less than delta implies norm of f of x minus f of a is less than epsilon. Okay, but norm of f of x minus f of a is less than epsilon means what? Norm of f of x. Here f of x, the function f of x is f1x, f2x up to fmx. The function f of a is f1a, f2a to up to fma. Since we are in the vector value function, by definition of norm, it can be written as square root of f1x minus f1a bracket square plus f2x minus f2a bracket square and so on fmx minus fma bracket square. This term is less than epsilon. This can be written in the form of summation, that is square root of summation I running from 1 to m fix minus fia bracket square. This term is less than epsilon. If this term is less than epsilon, then consider one term in that square root. So modulus of fix minus fia, this term is equal to what? Square root of fix minus fia square, which is less than this whole term square root of summation. पण ह्या सगळ्या स्क्वेअर रूट मधली या सगळ्या सम मधली फक्त आपण एकच टर्म विचारात घेतली तर ती टर्म ह्या सगळ्या ऍडिशन पेक्षा नक्कीच लेस असणार आहे. सो मॉड्युलस ऑफ f1x minus f1a which is less than this term and which is less than epsilon means fi modulus of fix minus fia is less than epsilon for I running from 1 to m, which implies what? this modulus is less than epsilon means what? The function f I x is continuous at point A and limit of the function f I x is equal to f I a for either from 1 to m. ओके म्हणजे आपण त्यातला फर्स्ट पार्ट प्रूव्ह केला. जर फंक्शन एफ ऑफ एक्स ही कंटिन्युअस असेल तर त्याची कोऑर्डिनेट फंक्शन f1x to fmx ऑल आर कंटिन्युअस ॲट पॉइंट E. रिमेंबर? You understand? This will be true in limit of the vector valued function. Same theorem तसाच आहे. Okay. Now we see the converse part. Conversely, suppose limit extends to a fix is equal to fia for either from 1 to n, that is each of the coordinate function is continuous at point A. Then we have to prove that the function f of x is continuous at point A. Okay, each of the coordinate function is continuous. So by using definition of that, for epsilon greater than 0, there exists delta I greater than 0 such that norm of x minus a is less than delta I. We have to implies modulus of fix minus fia is less than epsilon upon root m for I running from 1 to n. This root m will be taken only for adjustment. Okay, this modulus of here modulus come where? Why? Since these are all scalar valued functions. Okay, and scalar valued functions are defined from R into R. All the component functions are scalar valued functions. So here mod and let delta is equal to minimum of this. For each f1 we choose delta 1, for f2 we choose delta 2. So there are delta 1, delta 2, delta m deltas. Okay, so we take delta is equal to minimum of these m deltas, and for this delta norm of x minus a is less than delta modulus implies modulus of fix minus fia is less than epsilon upon root n. Now considering norm of f of x minus f of a. If this norm is less than epsilon, then we say that the function f of x is continuous at point A. Now what is norm of f of x minus f of a? Norm of f of x function f of x is f1, f2 up to fn. F of a is f1, f1a, f2a up to f of n. Fm of a. Okay, so which is equal to square root of summation I running from 1 to m fix minus fia square. Okay, fix minus fia square. That is f1x minus f1 of a square, f2x minus f2 of a square, plus and so on. Okay, so each of the term fix minus fia is less than epsilon upon root m. Here f1x minus f1x square. Therefore here epsilon square and square root of m square is m. Okay, so each of the term is less than epsilon square upon m. Epsilon square upon m. There are total m terms. Therefore, this sums becomes m square, m epsilon square upon m. So that m and m will cancel. Square root of epsilon square is epsilon. So norm of fx minus f of a is less than epsilon, which implies limit of the function or limit extends to a f of x is equal to f of a. That is limit of the function f of x is equal to f of a means what? The function f is continuous at point A. Okay, so converse part is also proof. म्हणजे आपण काय प्रूव्ह केलं? जर फंक्शन कंटिन्युअस असेल तर त्याचा प्रत्येक कंपोनंट फंक्शन कंटिन्युअस असतं, आणि जर प्रत्येक कंपोनंट फंक्शन कंटिन्युअस असेल तर ते फंक्शन सुद्धा कंटिन्युअस असतं. हे खूप इम्पॉर्टंट थिअरम आहे एक्झामच्या दृष्टीने सुद्धा. फॉर एक्झाम point of view, this theorem is very important. So read it and write the theorem properly. If you have any difficulty, ask me later.